The combined azole assay measures the level of the antifungal agents voriconazole, posaconazole, itraconazole and hydroxyitraconazole in patient plasma samples by liquid chromatography tandem mass spectroscopy. The analysis is undertaken to determine azole levels in patients receiving the drugs for treatment or prophylaxis of fungal disease. The results are highly specific and are not influenced by the use of antifungal combination therapy. This procedure is carried out in polypropylene 96 deep well plates. Polystyrene or polycarbonate plates must not be used. Timings are non-critical and will not affect examination results. Before you begin, ensure the daily mass spectrometer maintenance has been carried out on the mass spectrometer to be used. Collect your quality controls and standards from the fridge or freezer and print out a worksheet from your data capture system. External standards and quality control material can be purchased commercially and made up according to the manufacturer's instructions. Internal standards of D3 voriconazole, D5 posaconazole and D5 itraconazole should be made up to 1 mg per milliliter in methanol. These are stable for 5 years in the freezer and can be diluted to create working internal standards as required. Inclusion of these standards mitigates against any matrix effects that might alter the ionization efficiency and adversely affect accuracy and sensitivity. A working combined azole internal standard, D3 voriconazole at 0.2 mg per litre, is made by diluting stock D3 voriconazole 1 in 5,000 in methanol. 1 mg per litre of D5 posaconazole and D5 itraconazole are made by diluting the relevant stock solutions 1 in 1,000 in methanol. D5 posaconazole is used as the internal standard for hydroxyitraconazole. Working internal standards can be stored in the fridge and are stable for 12 months. To start the assay, label the plate. Follow the printed workout sheet. Write the well number to be used on the worksheet, starting with the standards, followed by the quality controls, and finally the patient samples. Vortex mix the standards and quality controls. Invert the patient samples and pipette 25 microlitres of each into the appropriate well. A 25 microlitre positive displacement pipette should be used for maximum accuracy and the tip should be changed daily. The pipette tip must be washed between samples with deionized water, then methanol, then fresh deionized water. Using a repeat pipette and appropriate tip, add 25 microlitres of 0.1 millimoles per litre zinc sulfate solution to each well to precipitate proteins. Followed by 100 microlitres of combined azole working internal standard for further protein precipitation. Seal the plate with heat-sealed foil. And rub over the surface to ensure that the seal is complete. Vortex mix for 1 minute on a multi-vortex, then centrifuge the plate at 2500 RPM for 5 minutes. Place the samples in the auto-sampler of the liquid chromatography unit, ensuring that the correct mobile phases are loaded. Mobile phase A1 is made up of 2 millimoles per litre of ammonium acetate with 0.1% formic acid by volume in deionized water. Similarly, mobile phase B1 is made up of 2 millimoles per litre of ammonium acetate with 0.1% formic acid by volume in methanol. Put the azole column In this case, a Phenomenex Kinetex 2.6 micron C8 column 30 by 2.1 mm with crud catcher guard inside the oven and set to 40 degrees C. Load the correct azoles tune page on the mass spectrometer. The mass to charge ratio transitions used to measure voriconazole and D3 voriconazole are approximately 350 to 224 and 353 to 224 respectively. The mass to charge ratio transitions used to measure posaconazole and D5 posaconazole are approximately 701 to 127 and 706 to 127 respectively. The mass to charge ratio transitions used to measure itraconazole and D5 itraconazole are approximately 705 to 392 and 710 to 397 respectively. The transitions used to measure hydroxyitraconazole is approximately 721 to 408. D5 posaconazole is used as the internal standard for hydroxyitraconazole. The run can be analysed and reported against the internal standards. After the run, post-analytical checks should be done by a senior laboratory scientist. The quality control values should be recorded to check that the run has passed, and equipment maintenance records should be kept. This is best practice for column and assay care, and should include back pressure on the UPLC, area for the top standard, and retention time. Once these checks are complete, the data can be entered into your hospital system to be reviewed by clinicians.